So welcome to National 4 Chemistry, and this video is on atomic structure. So we're going to be looking at atoms and at the particles inside atoms. So the first thing that we need to know is that elements are the building blocks of chemistry. Everything is made out of elements, and elements are found on the periodic table. Each element is only made up of one type of atom. So what that means is if you are the element carbon, carbon is only made of carbon atoms. Silver is only made of silver atoms, and iron is only made of iron atoms. Now, atoms themselves are made of three different particles, which are shown in blue, green, and red on that diagram. So the three particles are protons, shown in red, and you can see that they are found in the center of the atom. The ones in green are called neutrons, and they are also in the center of the atom. And the center of that atom is called the nucleus. So protons and neutrons are in the nucleus. And then finally we have electrons. And electrons are a lot smaller than protons and neutrons. And you can see that they are not inside the nucleus. They are around the outside of the atom in things called electron shells. Now we need to know different properties of protons, neutrons, and electrons. So we need to know their mass, we need to know their charge, and we need to know where they are found in an atom. Now protons are very easy. Protons have a mass of 1, they have a charge of +1. So remember, protons are positive, and they're found in the nucleus. The next one are neutrons. Neutrons also have a mass of 1, but they have no charge. So if they have no charge, they're described as being neutral, and neutrons are neutral, so that's why they've got no charge. Also, neutrons are in the nucleus. So neutrons, mass of 1, neutral charge, which means 0, and they are in the nucleus. And finally, we have our electrons. Now, electrons are so small that they do not have a mass. They have a charge of -1, and they are found outside of the nucleus in shells. So they are not in the nucleus. Now, the next thing we're going to look at is something called Nuclide Notation. And this is a way in which we can describe an atom using a symbol and numbers. Now, the symbols are found in your data booklet and on the periodic table, but the numbers you will have to learn to understand without your data booklet. So we have our symbol, and that's different for every element. There's always at least one capital letter, and then some elements also have a small letter beside it. We have a smaller number, which is called the atomic number, and the atomic number in the periodic table, the elements are organized from atomic number 1, going up 2, 3, 4, 5, 6, all the way to atomic number 118. So the atomic number, we'll learn what that tells us, but our second number, which is always the bigger of the two numbers, is called the mass number. So we have a symbol, atomic number, which is the small number, and the mass number, which is the big number. These numbers can tell us about the particles inside the element. So they are really important for working out what particles are inside each type of atom for each element. So the first number is the atomic number. And the atomic number tells you the number of protons in the nucleus of an atom. So here we have that C stands for carbon. The atomic number is always the small number. It's got an atomic number of 6, so we know it has 6 protons. This next one, that P is phosphorus. It has an atomic number of 15, so it has 15 protons. And finally, this next element, Br, is bromine. It has an atomic number of 35, so it has 35 protons. Remember, the smaller number is always the atomic number. So the next number we're going to look at is our number of neutrons. Or sorry, the next number is our mass number, which we will use to help work out the number of neutrons. So the mass number tells you the number of protons plus the number of neutrons. So the mass number is the number of protons and the number of neutrons added together. That's why it's always bigger than the atomic number. So you can use the mass number and the atomic number to work out the number of neutrons. So the number of neutrons is your mass number, the big number, minus the atomic number, the small number. So the number of neutrons is your mass number, your big number, minus the atomic number, the smaller number. So here we've got carbon, it's got a mass number of 12, it's got an atomic number of 6. Now, the atomic number tells us the number of protons, which is 6. Our mass number is 12. Our neutrons is our mass number minus our atomic number, big number minus small number. 12 minus 6, so it has 6 neutrons. Another example, using bromine this time. Well, its atomic number is 35, so it has 35 protons. If we need to know the number of neutrons, neutrons is the mass number minus the atomic number. So with a mass number of 80 and an atomic number of 35, that means it has 45 neutrons. And you can use a calculator for this. Now the next thing we need to know about atoms is that overall, atoms have no charge. They are described as being neutral. Now the only reason an atom ends up with no charge is because the number of protons, and protons have positive charges, equals the number of electrons. Electrons have negative charges. So if you have the same number of positive things as you have negative things, they cancel each other out and you end up neutral. And remember, the atomic number told us the number of protons. So in an atom, the atomic number also tells us the number of electrons. So putting everything we know together, we can, from the Nuclide notation, the mass number and the atomic number, work out the number of protons, electrons, and neutrons for an atom. And those are called Penn calculations. Penn for protons, electrons, and neutrons. So the three rules: the number of protons is the atomic number, the smaller number. The number of electrons is also the atomic number, because the number of protons and the number of electrons are the same. And the harder one to calculate is the number of neutrons, which is your mass number, your big number, take away, subtract your atomic number, your smaller number. So here we have an example. So we have phosphorus, it's P. It has got an atomic number, the smaller number is 15, and the bigger number, the mass number, is 31. Using those two numbers, we can work out the number of protons, the number of electrons, and the number of neutrons. So the atomic number is 15, and the atomic number tells us how many protons and how many electrons there are. So the atomic number is equal to our number of protons, so we have 15 protons, and our atomic number is equal to our number of electrons, so we have 15 electrons. And remember, the reason we have the same number of protons and electrons is that an atom is neutral, so those two things need to equal each other. To work out our number of neutrons, we need to use the mass number and the atomic number. So neutrons is mass number, big number, minus atomic number, small number, which is 31 minus 15, which gives us 16 neutrons. So here are 4 examples for you to try. And what I'd like you to do is pause the video, have a go at each one, and then continue playing and the answers will be revealed. So have a go now. So hopefully you have had a go at those yourself, and what you can see is that for oxygen, the atomic number is 8, so we know that the number of protons and the number of electrons are going to be 8. The number of neutrons is equal to the mass number, 16, minus the atomic number, 8, which also gives us 8 neutrons. Moving to the right, we've got hydrogen. Now it has an atomic number equal to 1. So immediately we know that the number of protons and the number of electrons are equal to 1. To work out the number of neutrons, it is the mass number, so the top number, minus the atomic number, the bottom number. So it's going to be 1 minus 1, which gives us 0 neutrons. And hydrogen is odd in that it's the only element that has no neutrons. Moving to the bottom left, the F. Well, F has an atomic number, remember the smaller number is the atomic number, of 9. So we can immediately say it has 9 protons and 9 electrons. To work out the number of neutrons, it is the mass number, 19, minus the atomic number, 9, which gives us 10 neutrons. And finally, that AS, which is arsenic, it has, oh, I've written that in wrong, sorry. So arsenic has 33 protons and 33 electrons, not 35, apologies. And the number of neutrons is 75 minus 33, which gives us 42 neutrons.